together with a range of people from the Species Survival Commission over the last 4 years. What we were really aiming to tackle is how do we predict species vulnerability to extinction due to climate change. There are so many predicted changes associated with climate change: technology, temperature, rainfall, as well as changes in carbon dioxide concentrations, and each of them has so many different effects and combinations of effects on species. How on earth do we tackle trying to actually predict what's going to happen? One of the ways that I guess the first thing to say is, quite logically, we took a very simple approach, as you would. If something's wrong with you, what you do is you go to the doctor. And the first step in getting effective treatment is always going to be a thorough and sound diagnosis. And this is really the part of the adaptation chain that we have set to work on. And we took a really simple approach to trying to get to grips with how to actually diagnose the problem. A very simple vulnerability framework that's based on sensitivity or a species' ability to actually persist in situ in the face of climate change, its adaptive capacity, how able is it to escape from the problem, and exposure, how much change is it going to face. If you're a combination of only two of these things, so for example, you're sensitive and you have low adaptive capacity but you're not exposed, then it's not a problem. Only if you have a combination of all three, so the purple triangle in the middle, that you're actually most vulnerable to climate change. So a very simple idea. And to make this workable, what we did is we set out to find out the sensitivity and low adaptive capacity traits associated with climate change vulnerability. And to do this, we got together a whole bunch of biologists from a range of different taxonomic specializations from around the world and asked them to tell us what are these sensitivity and low adaptive capacity traits. And they came up with about 90 different ones, and these form the basis of the framework for these two elements. And these are the sorts of things that they came up with. Sensitivity traits were those related to specialized habitats, narrow environmental tolerances or thresholds, environmental triggers that are likely to be disrupted, for example, migration or breeding time triggers, interspecific interactions that are likely to be disrupted, things like changes in food sources, disease, competition, mutualism, so a range of them, and also just being inherently rare means you're always going to be more susceptible to any kind of perturbation, fail to recover from it. So these are the sensitivity traits. Second, the low adaptive capacity traits. So those are traits that relate firstly to poor dispersal ability, and that's things like estimations of maximum dispersal distances, and in also species that might have barriers to dispersal. And secondly, it's about evolvability. Are you actually able to evolve yourself out of trouble? And things that might make you less able to do that are low genetic diversity, slow turnover of generations, or very low reproductive output. And the last triangle, the last of the three, is of course exposure. And to measure exposure, it obviously depends on the taxonomic group that you're looking at. But it's likely to be for terrestrial species, things like sea level rise, temperature change, precipitation change, and all the various aspects of that. Marine species, looking at corals, ocean acidification. So, as I mentioned, we've got the three different traits, and we talked about the sensitivity traits, the 5 of them, the sensitivity trait groups, the adaptive capacity trait groups, and the exposure. And so, basically, species that have traits associated with all three of those are those that are most vulnerable. This is the framework we've now tested out on a range of different taxonomic groups and species, and here is a whole list of them, but the ones that I'm going to tell you about today are the top 3: global birds, amphibians, and warm water reef and corals, so nearly 17,000 species, and these were our first 3 pilot groups. And so yeah, I'm going to be presenting the results of what we found from those groups. Recently finished work, it's still in review at the moment. show you some of these results. And I first want to acknowledge that this is the work of many folk, and these are my co-authors on the publication. I'm not going to go through all of them, but you'll see them later. So what we did is we used the framework and we set about collecting data for each species in each of these trait groups, which was quite a big exercise working with species survival commission experts. So on each trait, does the species have it, yeah, basically we went through that process. Then in terms of exposure modeling for each species, we took Bayesian range maps, we moved habitats and elevations with known unsuitabilities, and we looked at changes in temperature and precipitation, various aspects of that, and sea level rise. And for corals, we looked at exposure to frequent bleaching events and various acid waters, modeling up to 2050. And so gave us some very basic exposure estimates. And some of the species that were popping out as vulnerable overall, so qualifying under all three of those groups, are, for example, the specific royal flycatcher. It's sensitive because it has low tolerance of forest disturbance, it's reliant on a microhabitat, it has a narrow temperature niche and very small population size. It's unadaptable because it has very low maximum dispersal distances, and it also happens to be exposed and where it occurs to quite relatively large temperature increases. And so this one is flagged up. Here we have the vulnerable bird, relatively vulnerable bird. An example from the amphibian world, the spotted snarkborough from southern Africa. It's sensitive because it is reliant on a rainfall queue of increased precipitation for emergence and breeding. It only occurs in the southern tip of Africa, and that's an area that's predicted to face quite large changes in precipitation. So this is obviously flagged up. So there's a range of results that have come out of this work, but what I picked out to show you today are really where are the global priorities, the global areas of greatest concern for these three taxonomic groups. And I think what's particularly interesting is not only the purple triangle, which is obviously where are the most vulnerable species found, but also where are the areas that are the sort of lucky escapes, the good news. So areas where, for example, you have biological traits, sensitivity and unadaptability or poor adaptive capacity, but they're not actually exposed, or vice versa, species that are the yellow ones that are quite highly exposed, but actually have biology that means that they're probably a little more robust to climate change. So I'm going to show you a bivariate plot and then you understand where the different colour groupings come in. So these are the results for birds, and basically what you're seeing is concentrations of species in each of these three groups, and you can see that the Amazon, the sort of north-central Eurasia and the Himalayas, I'm not going to go through them all, but you can see the areas that come up as highly vulnerable overall, which is interesting information, certainly for global priority setting, but also the areas that turn up as lucky escapes in terms of high biological susceptibility only or high exposure only. To tell the story a little more fully, we need to look also at the proportion of species in each of these groups globally. This tells a little bit of a different story. Still, the Amazon turns up as a priority, so although there are large concentrations of species there, a large proportion of them, or a high proportion of them, are still climate change vulnerable. But we land up with the polar regions turning up as higher priorities, as expected, basically the Arctic and the Southern Oceans. Moving on to amphibians, once again we have the Amazon popping up as a global priority, which is quite disturbing, and also areas of Mesoamerica, it's tiny scale, the amphibian ranges are so small, but again also to see where the lucky escapes are. For now, obviously this is only projections up to 2050 and under a moderate scenario. Looking at the proportions of amphibians globally, a slightly different story. There's very low diversity in these parts of Northern Asia, but pretty much all the species there are climate change vulnerable. And again, interesting patterns as to where species are relatively lucky escapes. Lastly, moving on to the corals, what we found, not surprisingly, is that the coral triangle has very high numbers of species that are vulnerable. But when you look at the proportions, it's actually not just disproportionately high threat there, and in fact then the Caribbean starts to turn up as a high priority. A really interesting question is, are the species that are going to be most at risk from climate change also already threatened by non-climatic threats? And so here we're basically comparing in blue the level of non-climatic threat with climate change vulnerability in yellow, and the purple areas being those that are both. On the top we've got the birds, and what pops up is not the anthem, because of course there's lower at this stage level of threats there. So you can see that this is a priority, a relatively new priority based on climate change. But the areas of greatest concern, we have both, for example, in the bays and the Indian subcontinent pop up. You can see the areas turning up there. So interesting. And in terms of the amphibians, the highest threats are, again, very small scale, largely in the northern Andes and Mesoamerica. With the corals, you're landing up with the highest threats in the coral triangle, but again, additional interesting areas popping out in the Red Sea and Indian Ocean islands. So, I've shown you some results and introduced you basically to our framework. I think one of the most interesting parts about it is it doesn't just tell you about vulnerability and what's wrong. It's not just about your diagnosis, but it also gives you some very strong clues and guidance on how to actually tackle the conservation adaptation actions. So for example, we are obviously the most vulnerable species on the purple ones, greatest concern, highest conservation interventions, but your potential adapters can have some very specific needs. So for example, we'll hear Mom Stanley Price talk about potential value of assisted colonization. So these sorts of things are quite obvious results of the framework and how you might deal with adaptation. To end off, I wanted to talk to you a little about where this fits in with the Red List. At the Barcelona Congress, we landed up with a resolution that talked about getting climate change into the Red List guidelines, and that's now in the guidelines. Many people don't see it, but you'll find it in the new guidelines, and hopefully this framework will be integrated into the Red List as well. And I'll finish there. Thank you.